Okay, this is the cardiovascular system, lesson 2, looking at stroke volume, heart rate and cardiac output. So by the end of the lesson, hopefully you'll be able to define stroke volume, heart rate and cardiac output and look at the relationship between them and be able to explain the effect of exercise on those three different measurements. First of all, stroke volume. So stroke volume is the volume of blood pumped out by the ventricles in one contraction. And stroke volume depends on different things. First of all, it depends upon something called venous return. Venous return is the volume of blood returning back to the heart in the veins. If venous return increases, then stroke volume will increase. If we can get more blood going back to the heart, then we get more blood leaving the heart. And that blood returning to the heart is deoxygenated. Secondly, elasticity of cardiac fibres. Now the cardiac muscle is like any other muscle and it actually stretches. So the more the cardiac fibres stretch during diastole, which is the filling phase, then the greater the force of contraction. So if you imagine a water balloon, if you fill it up with more water, then when you actually pop the balloon, it actually pops with more force. Now obviously your heart doesn't pop, but if you fill your chamber up with more blood, then when it contracts, it can actually contract with more force. And this increases the ejection fraction, which is a percentage of blood pumped out by the left ventricle per beat. And finally, the contractility of the cardiac tissue, or the myocardium. The greater the contractility of the tissue, the greater the force. So if it can contract stronger, then it's going to actually provide a bigger stroke volume and contract with more force to pump more blood out. So you need to know what the stroke volume is dependent upon those three things. So in terms of during exercise, stroke volume actually increases as exercise intensity increases, but this is only up to 40 to 60% of your maximum effort. Now Starling's law is one law that explains the effects of exercise on stroke volume. So we've already said that during exercise it increases because we get an increased venous return. And we're going to look at venous return in the next couple of lessons. But we get more blood going back to the heart. If we get more blood going back to the heart, the cardiac muscle can actually stretch, and imagine your walls of your atria filling up like a water balloon. So as they stretch, they actually can fill up. So we get a greater diastolic filling, so they fill up with more blood. As they fill it with more blood, when the heart beats and contracts, because it's got more blood, it contracts with more force, pumping more blood out and increasing the ejection fraction, the percentage of blood leaving the heart. So Starling's law, you need to remember those 5 points relating to Starling's law. Okay, let's look at heart rate. Now, heart rate is the number of times that the heart beats per minute. During exercise, obviously the heart rate changes, and during exercise it actually increases. And this is dependent on the intensity. The higher the intensity, the higher the heart rate, because we need more blood getting pumped around the body. To work out your maximum heart rate, calculate 220 minus your age, so you could do that for yourself. A trained performer has a greater heart rate range, and that is because their resting heart rate is lower. When we come to look at the effects of training on the heart, we'll explain why that is. Okay, in terms of heart rate during exercise, here we have two graphs. On the left hand side showing maximal exercise, so anaerobic, and on the right hand side submaximal. And we have several letters that show different points on the graph. Okay, so first of all, as you can see at A, we get a little rise in the actual heart rate itself. And this is known as the anticipatory rise. This is due to the release of adrenaline before we actually start to perform. And this is preparing us for exercise. It's your fight or flight response. The sympathetic nervous system has kicked in even before exercise. So we get a slight increase in heart rate. At B, in both graphs, you can see we get a sharp or rapid rise in heart rate due to anaerobic work. So we need to get rid of the carbon dioxide and get more oxygen to your muscles. At C, which is only on the maximal exercise graph, heart rate continues to rise because we cannot meet those oxygen demands. Whereas at D, during submaximal exercise, we get a steady state as the athlete is able to meet the oxygen demands. At E, in both submaximal and maximal, we get a rapid decline in heart rate when we stop exercising, and then we get a slower, more constant recovery as the heart rate stays elevated slightly to get rid of lactic acid and other waste products. Now, as you can see, as we're performing maximally, we've got a longer recovery period, and that's because more lactic acid and carbon dioxide has been built up and we need to get rid of it. So you need to be able to describe the changes in the graph which reflect the exercise intensity. And finally, looking at cardiac output, this is the volume of blood pumped out by the heart per minute, and it's calculated by times in stroke volume by heart rate. So if we increase the stroke volume or the heart rate or both, then cardiac output will increase. Now obviously cardiac output during exercise increases, and there is a large increase in cardiac output especially during high intensity activity, and this is because we get an increase in heart rate and an increase in stroke volume. Cardiac output will increase as intensity increases until maximum intensity is reached. Also, when we come to look at the effect of training, if stroke volume increases and heart rate decreases, then we can maintain the same cardiac output, but that means that we have a lower resting heart rate, so that means we are healthier, and the fitter we are, the lower our resting heart rate. We'll come to look at that in the lesson. Okay, so we've defined stroke volume, heart rate and cardiac output, and we've looked at the effect of exercise on those three measurements of the heart.